I'd like to lastly show some of the policy that we can apply for security and how we can very easily set a baseline, a default policy that really allows someone that might be wearing the hat of a security architect to really to set a base policy that all applications and services deployed to a global mesh or potentially a workspace within the global mesh get applied. So you'll notice within this diagram, we have the little icons here showing that within the mesh, all this traffic is mutual TLS, so it's Istio mutual communications. However, it is permissive. So if I take a look at my namespaces here and notice what namespaces are labeled for an Istio injection, I have this test namespace. It's not participating in the mesh. So if I run this little helper pod, so I'm going to run it in my namespace test, it's just simply going to create a curl container and try and connect to my product page. So it's going to hit the product page just over typical Kubernetes service routing, which will still go through our sidecar, and this will work for me. So I'm going to expect that I'm going to get some HTML markup back as soon as my pod comes up. I'm able to consume, I'm able to connect to my service. Now that could be a problem. So if we're moving towards a zero trust posture, this is an internal service fronted by some gateways. I probably don't want rogue pods, rogue services that spin up in a Kubernetes cluster to be able to do something like that and consume my services. So let me put on the hat of a security architect, someone who's authoring policy that sets a baseline for all my services. And I can say for every service that's part of my book info workspace, and that is going to be scoped by selectors, which is a tuple of a cluster, which I have a star, so it's all cluster, and namespaces. So any cluster that's onboarded that has the T1 namespace or the book info namespace is going to be sucked into this workspace and consistently have configuration and policy applied. And so you'll see my two GKE clusters and then my edge that is my external load balancing into my clusters. So I can set a baseline policy for this. So let's call this book info baseline. And there's a whole bunch of things we could tune. We could set traffic settings, set egress, set circuit breaker and timeouts, but we're going to really just focus on security here. And so I can make this required, which means Istio mutual is going to be strict. All connections within the mesh need to have present client certificates. So if I save this within a second or two, that policy is going to be distributed to all my clusters. And if I execute that same test, I would expect now this is going to get rejected, right? I get a connection reset by peer, which is indicative that the server rejected me because I didn't present my client certificate. If I take a look at what's actually distributed within the mesh, well, let me actually not get the YAML. First, let's take a look at what got sent out. We'll see in my book info, I now have a default peer authentication policy that got sent here 30 seconds ago. If we take a look at this, we'll see probably what you'd expect. It's an Istio policy that's enforcing strict MTLS. We also can author service-to-service authorization policy, which is going to not only look at the client certificate, but it's also going to authorize based on the identity that's encoded in that. So I could potentially say, I'm only going to allow all the services within this workspace. So any service that is in the book info and T1 namespaces are the only ones that can participate here. And so if I had another namespace that was part of the mesh or another cluster that had a completely different workload, by default for this set of services, they won't be able to connect. And so if I look at now my authorization policies, we'll see we now have an authorization policy that got pushed out just a second or two ago. We have some default stuff that link all my gateways, but this default one came 16 seconds ago. And so let's just take a look at what that guy looks like, and then we can kind of wrap up and conclude. That didn't work as I expected. So you'll notice I didn't specify what namespaces. It's intelligently delivering me contextual configuration that picks up all the namespaces that are relevant for this collection of services, which I'm calling book info, which spans a couple clusters and a couple namespaces. So with this authorization policy, it's going to only allow traffic from pods, from services that are running and have a relation for this. So this is really moving us towards a secure by default posture, zero trust posture, in which all services have some sort of strong authorization and authentication tied to them.
And one final thing I'll call out, sorry, Adam, is that as we look at like that policy, which listed T1 and the book info namespaces, we know how to fill those in because of the selectors. But that's also specialized to the local cluster, right? So Adam, for example, in that config, we wildcarded the cluster names and listed specific namespaces. But suppose we listed in GKE East an additional T2 namespace. You would see that only in the policy in GKE East and not in West, right? Yeah. And so not only is this handling configuration distribution, but it's actually specializing that configuration correctly based on where that configuration is being consumed at runtime.
Awesome. So that's kind of the demo that we wanted to walk you through. Hopefully it was pretty evident how within just a few minutes and really only a few lines of config or policy, we're able to build a pretty powerful architecture, which has applications that are highly available, active across different clusters, across different regions. When possible, we optimize routing to keep it in cluster, have the least hops, make it most efficient. But if we have things that go wrong, we're able to fail across the clusters, introduce a legacy VM in a systematic and a safe way to start to modernize that potentially. And then lastly, establish a baseline security policy.